Building elements. So in this demonstration, you're going to see how we build up orbitals and electrons piece by piece in order to construct a given element. So we're going to start with one of the simplest elements that we have. It's helium. Helium is composed of 2 protons, 2 neutrons, and 2 electrons. And so what I'm going to do is I'm going to be dragging the orbitals, so 1s, 2s, 2p, 3s, and 3p into the box in the center. And I'll drag as many as I need to in order to fill up my orbitals for my particular atom, in this case helium. After I've dragged these in, I'll also drag in electrons. So I'll drag electrons into my orbitals, and we'll get to actually see them moving around, bouncing around a bit inside the orbitals. As I put the electrons in, you'll see the electrons being added to the orbital notation in the form of arrows. And you'll actually notice that they will have opposite spins. So let's go ahead and get started. So helium has 2 electrons. Well, we can fit 2 electrons in each s orbital. So we only need to have one very small s orbital. So we've got one s right there. So far, so good. Now we're going to drag the electron orbital into the orbital that we just added. So here's one electron, and you can see it bouncing around very nicely. And we have one arrow that's pointing up. Remember, each arrow represents how many electrons we have. Well, we're supposed to have 2 electrons because we have the same number of electrons as we have protons. Our atomic number is 2, so we've got 2 electrons. So I'm going to add in a second electron into this orbital. And you can see them bouncing. They're actually crossing each other, bouncing in opposite directions. And this is indicated in the orbital notation right here with one arrow pointing up and one arrow pointing down. We're perfect. Okay, so let's try another one. This one's going to be a little bit more complicated because we've got carbon here. And carbon has 6 electrons. So we can put 2 electrons in our first orbital. So let's go ahead and add those 2 electrons. One there and one there. And they're spinning in opposite directions. They're crossing each other. And our orbital notation shows one up, one down. Well, I know from the alphabet principle that I fill in 1 and then I fill in 2. Okay, so we're going to go ahead and plunk down the next one. All right, I'm going to go ahead and add my 2 electrons there. And so I added those in. They are also spinning in opposite directions, and you can see my arrows are pointing in opposite directions. So now it's time to go ahead and add in. So we've gotten 4 electrons out of the 6 that we need. So now we need to add in some of the p orbitals. So I know I'm going to have 1, 2, 3. We're going to have a maximum of 3 orbitals in the p section, so in our p sublevel. So, but this says we've added too many orbitals, so we need to think about how many orbitals this atom requires. So I'm going to reset, and we need just 1, 2. Oh, I need to add my electrons first. 2. I'm going to add those back. So I only need to add 2 more electrons. Well, I know because of Hund's rule that tells me I have to have 1 electron in each orbital before I can double up, that I'm going to need to add 2 orbitals. So I'm going to go ahead and add 1 orbital and plunk an electron into there. I'm going to add a second orbital and plop an electron into there. Okay, so now I have 1, 2, 3, 4, 5, 6 electrons. Way to go. Okay, this one's a little trickier because we've got 11. So I'm going to go ahead and start with 1s and put my 2 electrons in there. Then we have 2s. I'm going to add my 2 electrons again. So now I'm to 4 electrons. I'm going to add my orbitals one at a time, filling up 1 arrow at a time. So I went up, up, up. I had to put 1 electron in each orbital before I could double up. So now I can double up. Okay, so let's add it in the correct order. There we go, and down. So now I have 10 electrons that I've added. So I need to add my next orbital. And there's one more in there. So if we were to zoom in really closely to the main box to look at the atom, we could actually still see these electrons bouncing around inside. It would be really, really cloudy by the way that they move. And that's one of the reasons why we call this an electron cloud. So let's do our last one here. This is argon. So we're going to put our 1s down, 2s. I'm going to add 1 electron to each of my p orbitals. Before I double up, I'm following Hund's rule. And now it's time to double up. Remember, we go up, up, up before we go down, down, down. My next s orbital, I'm going to add 2 electrons. Then I've got my next p orbital. Two and 3. So now we have a total of 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. For argon, we needed to get to 18 electrons, so we are perfect.